Welcome along to this talk, where I'm going to be looking a bit at post-exploitation in Kubernetes. So a lot of talks about Kubernetes will look at what could go wrong with how you configure your cluster that might give someone access and how you can stop that happening. But I want to take a slightly different view and say what happens once the attackers got access. What can they do? Where can they potentially hide? How can they persist their access? And along the way, I want to take a bit of a look at some of the areas of Kubernetes and containers that you might not be aware of. So some of the more hidden parts of it that are interesting to explore. This actually neatly follows along from the last talk, and I want to say that I tend to say that Kubernetes is quite complicated, but compared to what was in the last talk, it's really not complicated at all. So don't worry, if you understood that, you're going to understand this. Before I get started, a little bit of that's slipped on several slides. Why has it done that? Missed a slide. Oh, I see what's happened. Before I get started, my slides have been unordered. A little bit of it about me. So I've been in information/IT/cybersecurity for quite a while. The fact that I call it information IT security probably tells you how long that might be. I have been focusing on container security for about 9 years now. So since about 2016, when Docker started getting very popular. My day job is a senior security researcher and advocate for Datadog. If you've not heard of us, we're a large provider of SaaS observability and security services. I do a couple of things to help out in the community around Kubernetes and container security. I help maintain the CIS benchmarks for Docker and Kubernetes. If you have ever used a CSPM product or a KSPM product, you've probably actually encountered those CIS benchmarks. They're kind of vendor-neutral hardening guides. I also participate in Kubernetes SIG security, and if this talk or any other talks you've seen give you kind of a desire to be involved in Kubernetes security, it's an open group, anyone can come along and we talk about Kubernetes security stuff. Also, you may have seen, if you've ever been to the Kubernetes website, you may have seen the little goose. The goose is in honor of a thing called SIG honk, because we mess around with Kubernetes security, and it was around a thing called the Untitled Goose Game, which is now kind of fading from time. But that's why you see goose whenever there's a security problem or a dangerous thing on the Kubernetes docs website. So I'm going to set the scene. Now, in our story, there are a lot of different ways that an attacker might get hold of a set of credentials, right? They might find them on GitHub. They might have used InfoStealer malware. They might have done a variety of things that gave them access. But for the purposes of this talk, our attackers are sat in one of Lausanne's lovely cafes, and they've noticed that someone was sitting at a laptop and then urgently got up and went out of the cafe to take a call, and they haven't locked their laptop. And they've left it open for these attackers to try and get in. And they get to the laptop and they realize that the person was a Kubernetes cluster admin, and they've left their session open. And so they have a period of time, let's say 45 minutes, to try and do as much as they can to keep that access, to try and retain access to the cluster and expand what they can do. So, this is what we're going to talk about, is some of the ways they could do that. So where could they hide? There's lots of different places in a cluster you can hide. You've got containers. Right? Containers are obviously the things that run our applications. Now, containers are just processes, essentially. So they're processes running on Linux hosts. We then have nodes. In Kubernetes clusters, a node is usually a Linux virtual machine. It could be a Windows virtual machine, could be a physical server. There are also things like serverless clusters. But for the purposes of this talk, we're going to assume our nodes are Linux machines, because in the vast majority of time they are. They could also hide in the cluster. Kubernetes has a lot of APIs and a lot of functionality. Perhaps there are opportunities there for our attackers to lurk and then come back at a later date and steal a whole lot of cool information from whoever this cluster does. Or they could hide in the cloud. Now, there's been other talks talking about cloud, and we could do whole talks about that. So I'm going to kind of ignore cloud for the time being. We're going to focus on containers, nodes, and clusters. So our attackers, they've got shell access. They're sitting there. The admin's pacing outside, obviously maybe not having a good call. What are they going to do? Well, the first thing they might want to do is they might want to get access to one of the nodes, right? Get a shell on a node. That sounds like a great place to start if I'm an attacker and I want to get persistence. In the old days of Kubernetes, whenever I say old days in Kubernetes, I mean anything more than a year ago, because it really changes very quickly. In the old days of Kubernetes, I used to be a pen tester and I pen tested clusters. I had written my own Kubernetes manifests to essentially give me a root shell on any node I wanted, because it was a very useful thing if you're a pen tester, get a root shell. It was based on a Docker command called the most pointless Docker command ever, because what it does is basically just drop you into a root shell. However, I used to have these manifests and I maintained them. But then the Kubernetes project, they tend to view things through the lens of everything should be done in Kubernetes. And one of the things they wanted to be able to do via Kubernetes functionality is debug nodes, right? So they basically rewrote exactly the manifest I used to use as a pen tester and said, this is now Kubernetes functionality. So you can just use Kubernetes functionality to actually try and actually get root shells on nodes. So what we're going to do, because why not, is let's do this live. We have got a Kubernetes cluster here. And this Kubernetes cluster, this is stock GKE. So this is Google's managed Kubernetes. This has just been absolute stock. I haven't changed any settings in it. This is what you get out of the box. And we've got 2 nodes. But this technique will work the same if you've got 2 nodes, 200 nodes, 2,000 nodes. It doesn't matter. What we can do is get a copy of the name. We can do kubectl debug node that -it because we want a shell and image is busybox. And that's just any container image. And we're going to hit enter. And if this is working, and we'll see whether our demos are going to be doing our stuff, that's a good start. We're then going to do the command chroot host. It's literally the same directories I used to use in my manifest. I don't know if they copied it. There we go. Root shell. I am now root on the host. So that's nice and easy. Great win for the attackers. It's been a couple of minutes, and we've already got root shell. They take a sip of their coffee, and they think, what do I want to do next? I've got my root shell. Let's go back to the slides. So the next thing they might want to do is they might think, well, we could go classic and old school. Why don't we add a new user to the host that we can use to come back? Now, this might work, right? Sometimes Kubernetes cluster nodes are exposed to the internet. Very much depends on the Kubernetes distribution you use. It's a fair point to say that there are, last I checked, 150 different Kubernetes distributions. Each one of them does things differently. Different defaults, different settings, different services. So you have to be a little bit careful which you're hitting. So maybe we could do this. And we could get an SSH authorized key. We could set up a user. We could give them, add them to the wheel group in Linux, which gives you sudo access. And we could use that to come back in. Now, obviously, if our administrator is running a well-hardened cluster, that is going to set all sorts of red alarm bells flashing across EDR and XDR. But let's say for the sake of this talk, they haven't done that. Because we're going to use this for one of our things anyway. One thing I will say, however, about this technique is when I was doing a lot of Kubernetes consultancy, a lot of people would say to me, well, we've locked down our environment. We don't want admins on the nodes. We've shut off SSH access. And then I had to give them the bad news about that kubectl debug command and say, sorry, you haven't actually shut off any access at all because they can just use that. But we're going to do that. So let's do that as the first demo work. And this gets to the point where I'm going to start copy pasting because if I don't, I'm going to make typos. Typos will not be fun. So first, we're just going to create an SSH key. Very quickly. Nothing special here. Just create an SSH key. No passphrase. We're hackers. We don't care. We've got an SSH key now. Great. And then what I'm going to do is have a really long command that there's absolutely no way I'm going to try and type. And all this does, this large set of bash, is basically just sets up a new user, adds it to the wheel group, and basically says, so this part, we can come back in and we can SSH to this with no password. Right? As long as we've got the key, we're good. So we hit enter, and that works. It gives us a little complaint, but it's worked. Okay, great. We now have our SSH backdoor, right? If SSH is open to the internet, we could take the key file we've just generated, walk away from the cafe, and we will come back to this node anytime we liked. Pretty good progress, okay? We're making progress. But we're not there yet. Because the next thing we need is, well, maybe SSH isn't open to the internet, right? And we want to drop binaries onto this host in order to actually do some kind of reverse shell. There's loads and loads of pieces of software out there that can create a reverse shell. We want one of these reverse shell things. And to do this, we're going to make use of some containers and namespaces. So one of the things, if you are doing CTFs, or if you're maybe you're pen testing or hacking into Kubernetes clusters, one of the things you might find is rather unsportingly, the cluster operators have hardened the node OSs. So GKE, for example, uses container-optimized Linux. And what container-optimized Linux does is it sets no exec on file systems. It also mounts file systems as read-only, which is very annoying. It means I can't just drop a binary anywhere I want to and run it, because it just won't run. However, this is a Kubernetes cluster node. It runs containers. That's what it does for a living. A container is just a process. So on any time I ever get access to a Kubernetes cluster node, I can always run containers, because otherwise it wouldn't be a Kubernetes cluster node. And within containers, I can run any binary I want. So awesome. Let's do it with containers, because that way we can get binaries onto the host, and we can run our binaries from there. So let's do that. we're going to do another demo. So what I'm going to do is I'm going to first, and this is where it gets a bit weird, I'll explain why though, I'm going to SSH back to myself. Now, the reason why I'm doing this is you can't actually run containerd, which is the software I'm going to use. You can't run commands from the shell I've got at the moment. It's not a completely full root shell. It's kind of a root shell for most purposes, but there's certain aspects of it that aren't the same and it won't work. So what we need to do is we're going to SSH back to ourselves, which is let me do, and then I can do sudo bash because I said I could do that. So now in a proper full I've SSH'd on root shell, I can do anything I want. So that's great. So what are we going to do next? Well, what we're going to do next is we're going to use a feature of containerd called containerd namespaces. Now, containerd, if you've not come across it, essentially it's the thing that actually runs the container, right? Kubernetes doesn't run containers. What it does is it basically delegates that to another piece of software. In the vast majority of Kubernetes clusters, that software is containerd. But containerd is its own daemon, and it is its own API, and it is its own toolset. So I can, on any machine that containerd is installed, if I'm root already, I can just talk to containerd. I don't have to talk to Kubernetes. I can just talk straight to containerd and say I want to do things, create containers, pull them, all that sort of stuff. Obviously completely bypassing any Kubernetes-specific logging or auditing you've got, because this isn't Kubernetes, I'm doing its containers. And I'm going to use this CTR client. You'll see here the command I'm actually running is CTR. That's a debug client that ships with containerd. There are other nicer clients available, however, they are not on by default. CTR is always, every time I've ever seen it, it's always going to be present, so you can always use containerd. And the command I'm running here is CTR namespace create sysnetmon. So I'm going to create a containerd namespace. Slightly confusingly, containerd namespaces have nothing to do with Linux namespaces and nothing to do with Kubernetes namespaces, because naming is really hard, especially with namespaces. So we've got three different things, all called the same thing. I'm going to call it sysnetmon because let's make the defender's job a little bit harder. Let's not make it obvious and say attackers were here. We'll create this namespace. Great. Okay, we've got a namespace. What do we need to do next? Well, we need to pull an image from Docker Hub. Generally speaking, on a Kubernetes cluster node, you're going to have access to Docker Hub because a lot of images live on Docker Hub. Therefore, you're probably able to pull stuff down to your machine from Docker Hub. If it's super, super hardened, maybe not, but the vast majority of times it's fine. So I'm going to pull this, and I'm going to pull an image from Docker from a user called sysnetmon, and the image is called systemd-netmon. Now, this image has nothing to do with systemd whatsoever, right? I created this image. And it's a very important point if you're using stuff from Docker Hub. Unless you're using an official image, they can be anything. They can be malware, they can rickroll you, they can do anything they like. So this is called sysnetmon, but I registered that user account last week, right? So it's not a real legitimate thing. But I can go and pull that. Great. It's going to go and pull all the different layers of my image, and it's going to give me that, and I've got it downloaded when it finishes unpacking it. And what I'm going to do once it's finished unpacking is I can now run a container. Great, so we pulled the image, now I can run a container. All at the containerd level. So we're going to do that. And the command I'm doing here is kind of long, and there's a couple of interesting points to note. The first point to note is you'll see just after -n sysnetmon, we're going to run it with net host. So we're going to say it's a container. I don't want you to run in some isolated networking, like the Kubernetes has its own network. I want you to use the host's network. So I want all the interfaces of the host machine, and I want all of the rights that the host machine's got on the network, which is the node's rights. Then we're going to say, I want you to mount the entire file system from the node inside my container, right? At which point I can access any secrets that are living on any other container on the node. I can access any secrets or any files that are on the node OS. And we're going to use our systemd-netmon image. And that will work. At this point, we've got a running container. Awesome. And this has got full access to the host. So if I can come back to this container, I'll have full access to the host anytime I want. And again, this isn't visible really at the Kubernetes level because what I'm doing isn't Kubernetes, it's containers. So the attackers are having fun. We've now got the place that we can download any additional binaries we want, and we can access it. Cool. But we have a problem still, which is we need some way of actually running a reverse shell. We need something because, the admin, he's pacing outside, his call is progressing. We need to get off his laptop. We need to go have a setup where we can come in remotely later on to do whatever we want to do and use our lovely execution environment we just set up. Now, there are lots and lots of C2 systems out there and other reverse shells, but I thought let's do this in a kind of slightly fun cloud native way because it's going to let me talk about one of my favorite pieces of networking software. Oh, before I do that though, actually, I'll do that, I'll come back to that one. Which is Tailscale. Tailscale is awesome. If you haven't used Tailscale, I thoroughly recommend using Tailscale because it's a great way of creating VPNs. It's also kind of useful. It's got several useful aspects of how it works from an attacker's perspective. Because Tailscale only needs, as described here, it will use other ports, but it falls back to what's called Tailscale's DERP network. And this is a network of relays on the internet managed by Tailscale. And all you need to use Tailscale is outbound 443 to their DERP IP addresses. Now, the vast majority of machines are going to have outbound 443 from a node to the DERP network. And all the traffic you'll see is HTTPS traffic going to Tailscale's DERP network. And from an attacker's perspective, we also only need 443 outbound. So it's going to work in a number of, a pretty restrictive and easy way. Now, the other good thing about Tailscale is it consists of 2 static Golang binaries. And you can rename them. So you don't have to call them Tailscale, because Tailscale is kind of an obvious thing to see if you're not expecting it to be there. We can call them anything we like. And then we can rename them. We can say, I'm going to run this binary. And then once I've got it running, it's going to go out there and it's going to connect out to the internet for me. And it's going to give me my backdoor. And then I can come back into it from anywhere else in the world that I can contact Tailscale, which is basically anywhere else in the world. Before I do my demo, though, I did skip a slide, but I should mention. There was another way I could have got my persistent execution environment. And I want to mention this because it's a really fun Kubernetes feature. It's a thing called static manifests. The way this works is Kubernetes, when it's bootstrapping itself, it needs to start up containers without Kubernetes, the API server, being present. So it needs some way of running a container without everything being up and running. And what it does is the kubelet, which is the node agent, the thing that actually manages the containers, it has a directory usually. It's usually var etc manifest Kubernetes. And what it does is any file that's placed into that directory, it says, I will try and run that container. So as soon as you create a file in that directory, it says, cool, I will go and start a container based on that file. That's another way of doing what we did with CCR. But it does create a file that's kind of visible to the Kubernetes level, and people might look at that directory. So we didn't do it that way this time. Anyway, let's go back to our demo, and let's exec into our container. So we've got our container running. We can now execute a shell into our container. Right? So I'm now running inside my little containerd container that's running on the host. And the next thing I'm going to do is I'm going to start Tailscale. This will scroll down, which it will. So I start up the server, which should be happy. And then I start up the client. And this, we've got a key that we're passing to it to authenticate back to my Tailscale network. Okay, and it will go away and happily connect out. Now, the other cool thing about Tailscale is you can have ACLs. So this is my Tailscale network, and you can see there's a new machine popped in called CafeBot. So that's the one the client I just ran, right? And what I'm going to do is I'm going to set an ACL tag on that, and I'm going to say, you are a bot. And what that does is it means that bot, because I've set ACLs up, it can't talk to anything. Because we don't want our bots talking to each other. Maybe there's lots of cafes we're going to go around and try and hack into people's laptops. We don't want these bots knowing about each other or talking to each other. So the way Tailscale ACLs work is they essentially will say, you can specify what you want to talk to each thing. So basically my 2 controller machines, Killian and Haggis, can talk to the CafeBot, but the CafeBot cannot talk to them. Awesome. So once we've done that, we should be able to start a new shell. And this is our attacker's machine. He can just do Tailscale status. This is why I should always copy paste. Tailscale status, we've got that working there. And then he can just do Tailscale SSH root at CafeBot. So another one of the really fun features of Tailscale is it embeds an SSH daemon. Right? I don't need to run SSHD inside that container. I just need to run Tailscale, and it has its own embedded SSH process. And if anyone's looking at the processes running on the host, they will not see an instance of SSHD. What they will see is Tailscale. Oh, actually, what they will see is systemd netmon, because I've renamed the binaries to be systemd netmon. So as far as they're concerned, is there's 2 processes running called systemd netmon. But we can do that. Awesome, right? We're back in from the outside. We now have a full SSH shell from anywhere in the world into our compromised bot machine. Great. It's looking up. But the attackers are having a kind of a fun day. They've still got a little bit of time left. What can they do now? Well, there's a problem. And the problem is the credentials we're using to do all this are going to expire. Most managed Kubernetes environments, things like GKE, AKS, EKS, the credentials expire. Right? They're based on the IAM service provided by the cloud provider, and they won't last forever. So we can't just copy the file that we're currently using to access this cluster. We can't copy it and run off and come back in a month's time because those credentials expired. What we need is a set of persistent credentials that we can use later on when the meeting's over, we've moved away from the laptop, we're running over Tailscale, so we need that. And we also would quite like to avoid some of the things that might trip us up, like Kubernetes audit logging. So to do this, what we're going to do is we're going to get a set of credentials, we're going to create them, and we're going to get access to a thing called the kubelet API. Now, I mentioned the kubelet earlier on. I said it's a node agent. It runs in every cluster, and it runs on every node in every cluster. And it has its own API. The API runs on 10.250 TCP. And if you have access to the kubelet API, you can do fun stuff like execute commands in every single container on the host, read the logs of every container in the host. So pretty much anything you want. And from our purposes, the cool thing about the kubelet API is it does not show up in audit logging. Kubernetes has audit logging. Nothing that goes to kubelet API shows in audit logging at all. It also bypasses a thing called admission control, which is a way of restricting what people can do in Kubernetes. Kubelet API, nothing to do with admission control. It just works. So we need some creds that can talk to this thing. How are we going to get those creds? Well, we're going to open a third shell because we can never have too many shells. And then we're going to go back and I'm going to run, and I'm going to come back and explain this command a bit more in the next slide. But this is going to generate actually I'm just going to make very sure I haven't got this file already there. No, I don't. Good. This is going to generate a new kubeconfig file. And I'll explain what this utility does in a little bit. But we've got a new kubeconfig file that can talk to the kubelet. We're then going to copy it to the clipboard because we need to put it into our little container. And then we're going to go back into our container. And we're going to kubelet user.config. We're going to use vi. And we're going to put it in there. So that's a set of credentials. And once I've got those credentials, I'm going to use a little tool called kubelet to talk to the kubelet API, make sure it's all working. And if that's all working, okay, that worked. Now, kubelet you might think by the name that it's kind of like kubectl. This is an official Kubernetes utility. It's actually not. It's from a CyberArk researcher. They got really annoyed by the fact that the kubelet API is basically undocumented. The Kubernetes project have deliberately have not documented it fully, so they went and reverse engineered the code, which you can do. It's not that hard to read. And they wrote a cool utility that lets you talk to the kubelet API. And you just pass it a set of creds and talk to it. And what we can see here is this is just listing all the containers. But I could also execute commands in all those containers. And it's important to note the credentials I use there work on not just the node I'm on, but on literally any node. So we can now tailscale back into the cluster, we can hit all the nodes, and we can execute commands in any cluster we want. Sounds like a good time. But you might say, Rory, how did those credential creation work? Because I just said that we need to use GKE IAM, or AWS IAM, or AKS, wherever cloud you're in. So that leads me on to one of my favorite APIs in Kubernetes. And I do know it's a sad idea to have a favorite API in Kubernetes. But I do. And it's this one. It's a certificate signing request API. Because whilst all of the managed Kubernetes providers that you're used to using give you authentication and authorization mechanisms, there is also one built into Kubernetes, and it's called the Certificate Signing Request API. The Certificate Signing Request API is really cool because if you're an admin and you have rights to the API, you can issue new credentials, which are client certificate based. This works in every form of Kubernetes apart from Amazon EKS. They disabled it. For a long time, they hadn't documented why they disabled it. There was just this GitHub issue with people complaining about why doesn't this work. And eventually they put it in their docs and said, we turned it off. They never said why, but I think it's for security reasons. And I'll explain why it was a good idea that they turned it off. So there's a couple of things about the CSR API. I can create any user I want. I've got rights to the API, including system accounts. So including things that are internal to Kubernetes. I can just say, give me a set of credentials with that username, please. And it will. There is no persistent record that I've created those credentials in Kubernetes. Kubernetes notably has no internal user database, and therefore the CSR request itself expires after about 15 minutes. And at that point, unless you have audit logging turned on, there is no way for you to know that I created those credentials. And if I come back and use those credentials, it will appear to be whatever user I created them as. So the one I created earlier was one called Kube API Server, and we're going to use a different one in the next demo as well, and that's all you will see in the audit logs. The other fun thing, which you might think, well, hang on, if there's no persistent record in the cluster that these things exist, how do I revoke them? That's the fun part. You don't. You can't revoke them. Kubernetes doesn't support certificate revocation. There is an open issue, which is now 9.5 years old, about the fact, I'm not joking, it's Kubernetes issue 18982. Again, I've memorized that because I've been to it so many times, saying why don't we have certificate revocation? And there's a long thread you can read about why. But the basic, from our perspective, means that if we ever get temporary access to someone's credentials that lets us use this API, we can create credentials that can't be easily revoked. There is a way of doing it. Basically, you have to rotate the entire certificate authority of the cluster. But I will warn you now that is a disruptive operation. Microsoft stocks for their version of Kubernetes say they get 15-minute downtime. So it's not something you want to do lightly. And also you would have to know it happened. And there's no persistent record unless you're usually looking at audit logs. So we can use the CSR API. And one of the things, if there's anyone in the audience who's done a lot of kind of like scanning around of Kubernetes, is you've probably spent the last 15 minutes looking at me going, Rory, why are you bothering creating new containers? What a waste of time. Because why don't you just use CSR API and come back in over the internet? And that's where you get to another fun fact about Kubernetes, which is all of the major distributions, by default, put the API server directly on the internet with no restrictions. So if you take the outbox defaults, your API server goes on the internet. There are 1.9 million. Last I looked, which is I think last week, I had a look on Census, and they said there's 1.9 million things that look like Kubernetes API servers. That's up from 1.4 million a year ago. So people are putting more and more of these things on the internet. And this means if I have a set of credentials for a cluster, I can hit the cluster over the internet with no problems. Let's do that. Why not? Right. So here I am back out on a place on the internet, and we're going to use this command here. I said I'd explain what this is. This is a little command I wrote. Basically, it just automates, does nothing clever, right? It just automates 3 API calls. I'm a lazy pen tester, and I hated doing this manually, because basically you have to go and issue a certificate signing request, you have to approve it, and then you have to put it into a kubeconfig file. It's kind of awkward. So I just wrote this, which is the Gallic for certificate, in case you're wondering why it's called that. And what we're going to do is we're going to say, give me a new user, and call it system GKE common webhooks. This is an internal GKE account. All of the different Kubernetes flavors have their own internal system accounts. I'm going to use this one. And just put it in, chuck out a file. And it'll say, sure, of course, you're an admin, you have access to CSR API. And one of the fun things is, let's have a little look at the expiration date on that. It's 2030. So these creds can't be revoked and last until 2030, and will appear in the audit logs as a system user. The exact duration on these accounts varies distribution to distribution. So Microsoft, and most of them are a year. GKE is 5 years. I don't know why they're 5 years. I have pointed it out to them, and they said that's not a problem, that's working as designed. I said, okay. We've now got a set of creds that will last 4 or 5 years. So let's quickly actually try these out. And we're going to do this little command here. This is kubectl auth can I. So this is a command that basically says, tell me what I can do. Give me a list of all the rights that I've got. And when I do that, I get lots of fun rights. So this particular account has it's got config map star, endpoint star, ingress star, node star, pod star, service star, lots and lots of stars. Stars in Kubernetes mean all the rights. So this basically says I can do anything to any pod on the cluster. So as long as I've got these creds, I can come back in and I can execute commands in pods. I can do anything I want. It also has some fun stuff like, where is it? Yeah, down here. Get secrets at cluster level. So this can get any secret in the cluster and just dump out the content of the secret. So this is a pretty powerful account. And my attackers now have a set of credentials that they can come back in with anytime they want for the next 5 years from anywhere in the internet, assuming that the cluster hasn't been locked down, and get any access they like. So that's pretty fun. And honestly, you could probably do this in maybe a much shorter talk, but I thought it's kind of interesting to look at the other stuff as well. But we're not fully satisfied, because I said to you this doesn't always work. Specifically, it doesn't work in Amazon EKS, because they very unsportingly turned off the API. Does that mean that we can't do this to EKS? We can't come back in, we can't create creds? No, it does not. because we can use the token request API. So in the old days of Kubernetes, actually old days is slightly longer, this time is 2 years. In the old days of Kubernetes, they had a lot of service accounts. And service accounts are used by the components of Kubernetes to talk to each other, right? So if a component needs to talk to the API server, it has credentials. These used to be static secrets that never expired. So if anyone is unfortunate enough to still be running Kubernetes 1.22 or earlier, you still have this. The problem with these is anyone who could read the secrets even once got access to a whole load of non-expiring JWT tokens that would last forever and would give you all the access you ever wanted. This was recognized as a bad thing. And so we moved to a thing called the token request API, where tokens are issued dynamically as needed for all the different system accounts. However, anyone can use the token request API if they've got the right rights, and we can use the token request API to create credentials. So let's do that, because this would work. That gives you the kind of thing on. Now, in terms of expiry, this isn't quite as good. The expiry depends on, again, the distribution. And this is one of the hard points of Kubernetes security. Anyone says to me, how does this work? And I say, which distribution are you using and which version is it? Because it changes. In EKS, they only last 24 hours. So you're going to leave a bit of a trail because you're going to have to come back every 24 hours and renew your creds. GKE is max 48 hours. AKS is max a year. So it is pretty variable, and you might get a year-long creds out of this. And they're JWT tokens. Again, you can't revoke the token because it's a JWT. It's just a signed token. So these are irrevocable creds as well, which is pretty handy for an attacker standpoint. And no persistent record of the fact you've used this API. As long as you're part of the audit log, there's nothing that says, there's 10 sets of credentials have been issued for this system account. There's no record. So you don't have to worry about being caught that way, unless they have audit logging turned on. So let's do that, because we get to try out. We're going to use a different tool. This one is called Tokan, and it's incredibly similar to the other one because I am a lazy pen tester. This just automates the process of creating a new service account token and actually putting it into a kubeconfig file. We're going to say we want to do something out of the kubesystem namespace, because the kubesystem namespace is where all of the interesting stuff is. And we're going to use, next sad thing for me to admit, my favorite service account, which is the cluster role aggregation controller. And there's a reason why the cluster role aggregation controller is my favorite service account. So we're going to issue these creds, and it'll say, sure, yep, you can do that. We're going to give you a set creds. We're then going to do that same command where we list all our permissions for that account. Now, these permissions here, these are not very interesting. These are boring permissions that everyone gets. And these permissions here are also boring permissions that everyone gets. There's only one interesting set of permissions in this output, which is here. This particular service account has the right to do things to cluster roles. And it has a very, very interesting right, which is that one, which is escalate. Usually, if you're in Kubernetes, if you're allowed to create new cluster roles, you can't create one that has more rights than you have, which is a defense against privilege escalation, right? Shouldn't let people do that. Unless you have the escalate right. Because the escalate right, by design, allows you to escalate your privileges. The clue is in the name. One of the fun things about Kubernetes RBAC is most people only think of it as having like get, list, patch, update, like the standard CRUD verbs. It can actually have any verb you like. And a lot of tooling, sometimes tooling will not find the escalate verb because they don't know it exists. There's a set of special verbs, escalate, bind, and impersonate. And sometimes tools don't even notice they're there. In this case, we have the escalate verb, though. The escalate verb is amazing because it means I can be anything I want. I can have any rights I want at any time I want, which is exactly what we like to hear. So what we're going to do is we are just going to edit our own rights. We're going to say we would like different rights to these. We would like more rights. So all I do here is I do a kubectl command. So this is just the Kubernetes administration tool. And I tell it to use the credentials I just created. And I say, I want to edit the cluster role that we've got. And it says, sure, of course you can edit it. And then I'm going to go get this because it's YAML, and I will mess up if I try and type YAML. YAML is white space significant for everyone who's not had the unpleasant task of using it. So you have to be very careful. And all I'm going to do is I'm going to do that. And I'm going to paste in a set of rights. And those rights basically say, give me everything. I would like star, star, star. Star, star, star in RBAC land is give me all of the rights. Hopefully none of your users ever use star, 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 because it's amazingly dangerous. But for the purposes of this, we're attackers. We don't care. We want the dangerous thing. Let's be cluster admin. So once we've done that, we can go back and we can just issue the same command again. And it looks very similar in terms of the rights we have, except we have that. The magic line. Star, star, star. I'm now cluster admin. I can do anything I want to this cluster. I can delete stuff, create new users, do anything I like. Because I had that one thing, that one little escalate right. It's super important. So that's another way of doing it. That works everywhere. That works on any distribution that I've ever seen. As long as you have rights to the token request API, you're good. You can just use this to create creds and do anything you want. And again, come back in over the internet, because most clusters, not every cluster is going to be exposed to the internet. And if they're not, you can go back and do all the tailscale fun we just did. But a lot of them are. So let's talk about how we shouldn't let this happen, because this is bad. If we're running Kubernetes clusters in production, we don't really want people to be able to do these things to us. So how could we have avoided what just happened? First, how do we detect all of this? Right. The most important thing is Kubernetes audit logs. A lot of the techniques I use today are only visible in the audit logs. So things like creating new certificate signing request users, things like exploiting the token request API are only visible if you have audit logging turned on. Importantly, a couple of things. First up, retention is important. Imagine a scenario where this isn't a coffee shop. Imagine a scenario where this is something like, for example, someone who's been hired by your organization and turns out to come from North Korea. Does this, walks away, comes back 6 months later. If your logs aren't around for 6 months, you're not going to know what went on. You're going to have no chance of putting this back together again. None of this, by the way, turns up in things like cloud logs. We're talking directly to Kubernetes APIs, so all the stuff that came from last time, this is not going to show up in those logs. Important point about managed Kubernetes, so if you're using your cloud provider's Kubernetes, is you can't change the configuration of auditing. The auditing is set by them. So they say what will be audited. Usually the problem is actually they audit too much rather than audit too little, but you can't change it. And one thing I have noticed, I haven't unfortunately got around to anything like all of the managed Kubernetes providers, but I did find a couple where audit logging was not an option. You couldn't turn it on. And in a managed Kubernetes provider, you have no rights to change that configuration. So literally, you can have no audit logging. I would thoroughly recommend that you can check with your managed provider, make sure they allow it, make sure you know how to get your logs and how to retain them. If they say you can't turn that on, say to them, that's not acceptable, because it's really not. Other things you can do to detect it, node agents. Obviously, hopefully we're all running EDR or XDR on all of our Kubernetes cluster nodes. If you are, some of the basic stuff I did, the SSH, adding a user, that should, light up like a little Christmas tree. But there's bypasses there, as we all know. There's been loads and loads of talks about how you might be able to bypass EDR. Node logs, ensuring you have a logs from the processes running all your hosts centrally. So make sure you've got those stuff in the central location so you can do hunts and actually find out what's going on. And this last one, this is kind of interesting because it's not anything like as easy as it sounds. Know what good looks like. So if you're using Kubernetes and you're using one of the big distributions, they all have different processes which run on them, all have different services and different pods. What does good look like? Because would you recognize if there was a thing called systemd netmon running on one of your nodes, and you might just think the cloud provider put it there? Because they do put all sorts of funny stuff running on nodes. If you know what good looks like and you know what stuff they've given you to run, you have a much better chance of noticing a random new binary that's turned up that shouldn't have been there. And practical hardening. What can you do to stop this? How could we essentially have this not happen to us? First up, take your clusters off the internet. Don't put them on the internet. I do not know why the cloud providers thought this was well, I do know why they thought it was a good default, because it makes things nice and easy to use. But from a security standpoint, it's terrible. Because if your cluster API server is directly on the internet, you are one mistake, one lost set of credentials, one, malware stealing a file that gives someone the rights to do what I just did there. You're one mistake away from a disaster. Kubernetes, the way it operates, is fundamentally distributed remote command execution as a service. That's literally what it does for a living. That makes it a very valuable attack target. Because if I can do distributed remote command execution, that sounds like a great thing if I want to do, for example, mine cryptocurrency in your cluster. There have been cases where this happened to people. Best thing to do, take your cluster off the internet. That will help make this harder for them to exploit. And the other thing is least privilege. So imagine a scenario where our admin who went off to have his meeting wasn't cluster admin. Imagine a scenario where he didn't have the rights to do the CSR API. Because let's be honest, day-to-day troubleshooting, you don't need to use the CSR API. You don't need to use the token request API. You may not even need kubectl debug node. That one's debatable. You probably do need kubectl debug node, but you don't need those big, powerful APIs that let you create credentials. If we had been doing the very boring old security thing of least privilege, that might not have happened. We might have a different story. And I'll leave you with the words of the great Ian Coldwater, who said that we are all made of stars, but your RBAC should not be. Thank you. I think we have a couple of minutes for questions, if anyone's got any questions. Or if not, and everyone's going to get beer, that's fine too. Should be good. It's awesome. I didn't see anyone. If you're not waving hard enough, if you do have a question, so I'll say thank you very much for your time.